This is a video about the theory behind how this matrix is set up. And we're also going to do a little bit of testing on it. In the last video, you could see that most of the switches were working, but we had some damaged switches, and the question is, what's going on there? So, first of all, a little bit of theory. So this is the switch matrix for an F14 Tomcat. And this is the matrix that we're trying to interface with the Cobra pin. And you can see that it has columns and rows. The columns are green wires with a colored stripe on them. The rows are white wires with a colored stripe on them. And now the green ones are the outputs, basically, and the rows are the inputs. So I'll leave a link for other videos explaining how switch matrices work, but the long and short of it is, if you look, ignore the poop emoji here, the important thing here is that numbering right there, 0 through 7 on both sides. Now that is 0 through 7 on the switch matrix out. That corresponds to the columns, all right, on this matrix. And the switch matrix in 0 through 7, you can see there's a gap in the middle where if it was a direct switch it would be ground, but it's ignored in a switch matrix configuration. So that is going to be your rows, which are the white wires. Now we look at the actual Cobra pin over here running, and you can see that they are indeed connected that way. Now, if you've got a sharp eye, you'll notice that the very edge, this pin right here, is not connected. And that means there's only 7 pins going there. And if you look at the first column, you'll see it's plumb bulb tilt, ball roll tilt, credit button, right coin chute. All of these things are part of the cabinet. And of course, on a playfield, you're not going to have any of those cabinet switches existing. So on a machine that you're setting up a connection like this, there's no point in having these at all. So in order to maintain the same sort of switch matrix reference, I deliberately leave off the green brown. So it's not part of the playfield, and it's not going to be part of this. Now the next thing you can see, if you're looking at the Cobra pin connections, is you can look on pinball makers, and you can see this is the numbering for the switch matrix. So you have the same 8 columns in both cases, 8 columns and 8 rows, and the numbering for each one. And it shows you, in fact, this one's kind of nice, it shows you that the rows are switch matrix in, and the columns are switch matrix out, in case you get it mixed up. It's not a huge deal. If you do mix them up, just you got to flip the connectors around if you make that mistake. So, how do these get defined in MPF? We can go and look really quick. Now I use Linux, so if you're using Linux, you'll recognize some of this. If you're not using Linux, if you're using Windows or Mac, you'll see the same file, or you'll create the same file. But it will, your editor will be different. Anyway, what I've done here is, if you note over here, the switch matrix begins with 1032 on the Cobra pin itself. Now we're ignoring this first column, so we're going to start with 1040. And indeed, 1040 is the first switch I define. And if you look at the switch matrix, since we're ignoring the first column, 1040 is going to be playfield tilt. And that's why I call it PF tilt. Then out hole switch, 141 all the way down. And so that's, you can see it's pretty simple. That's exactly how you define a switch. And that's really all you have to do for a minimal system like this. Then we're going to look at the system actually running right now. And on this particular machine, I'm not sure why I get some error messages that can mess with the formatting a little bit, so sometimes I resize the window. Now the way you can test this is you've got your connector here and you've got a little jumper wire, and you can do something like put the jumper wire in one pin on the green, for example, so that's one column, and then you can connect that to one of the rows. Now in this case, I'm connecting one of the greens to one of the rows, and you'll notice S center trough, or S left center trough, is active. You pull it out and it goes away. Put it back in, goes back. Put it in the next one, you get S shooter lane. And so you can go about and do this and test each one of these connectors. So you can see, for example, excuse the word, playfield tilt was right there, and then the shooter lane is right here. So what I've done, the check marks mean that I've tested each one of these connections. Some of them won't have anything, so there was not a device set here for these that say not used, and so I simply didn't define those in my configuration, but everything else tested out positive. It works. So we know at this point that the configuration is complete for switch matrix, and we know that the physical wiring up until this point, which is the harness I created in the previous video, that all works. So the next step is to plug this back into the playfield, run these same tests, and now we're going to see which ones are physically there, which ones are physically broken on the playfield. There may be some wiring broken, but that's how you're going to debug it at that point, and you know up until that point on the playfield that everything's correct. So next video we will test again on the physical system, and we'll do a little debugging there.